Hi, hello. My name is Christian Josue Muñoz Ramos, and I am here to talk about the article kinetics and metabolism of mercury in rats fed with mercury contaminated rice using mass balance and mercury isotopes approach. Okay. Um, Introduction. It is toxic to the central and peripheral nervous system. Inhaling mercury vapor can be detrimental to nervous and immune system, to the digestive system, and the lung and kidneys, with sometimes fatal consequences. This is generally found in two variants, pure mercury and methyl mercury. This is substance, unfortunately, despite many of its consequences, is usually found in various famous such as fish, which, by the way, is found in its organic form, which is methyl mercury. Uh, what is the most toxic form of mercury? Uh, okay. Uh, in short, this element in its methyl form is easier to absorb by the body, which makes it more dangerous since this will cause different parts of the body to be affected by it due to the ease of transport that it once of the once has in the bloodstream. Why this study? Um, this study was carried out with the intention of seeing how the body processes mercury and how much is expelled from it through mass balance modeling. This will be carried out the isotopes of mercury which are 199 and 202. This is the isotope of mercury. Uh, Methodology. Okay. The methodology is uh, the next. 8 rats were selected, which were selected 4 females and 4 males, and all had an approximate weight between 70 and 18 grams, meaning that there was not a very significant difference between all the rats to have the least amount of errors. After that, rats will be kept in environment with light and dark cycles, simulating day and night. And these rats were fed with rice contaminated with mercury although it should be noted that they had free access to food. After several days, 90 to be exact, these rats were suffocated by dissecting some parts of them, such as the liver, brain, blood, among some others. Well, continue to the methodology. Well, as mentioned in the slide, the amounts of rice consumed by each rat were recorded, as well as what each one weighed. This weighing them was done weekly, as well as the analysis of feces and urine. This was done in order to carry out the mass balance of the mercury resting in the rats. Well, that was the process, so now we go with the results. Here we can see how the T mercury concentrations are presented in different organs. In this case, the graphs are of two selected rats, which are C4M, which is male, and the C4F rat, which is female. We can see in the following graph how in both the T mercury concentrations is quite high in the kidney, followed by higher phases. In the same way, we can see that although mercury can be quite neurotoxic, it is not the place that is seen more affected by this substance. Thus, we can also observe that urine is the place where T mercury is less excreted. Then we will go track the graph of methyl mercury to see if there is any difference with respect to this other bearing. Well, tubing with methyl mercury had no visible effects on the deployment of the rat, and we see the absorption. This substance is quite similar with the kidney as the area with the degraded accumulated fluid by the hair, and the brain being one of the less contaminated by this substance. Well, the amount of mercury recovered was 83.8 in the case of male rats, and in the case of female it was 77.2. From this data it could be observed with 95.3 recovery in the male and 92.5 in the case of females. All based on the data collected, we can see that only 13.2 of the methyl mercury of the rice was recovered, and therefore only to confirm the percentage of methyl mercury in the hair. blood and muscles, they represent 94 of the total. Continue to the results. Uh, uh, Within the article, we have the following table which shows us the absorption factor of mercury in its two different isotopes. For this explanation, we are not going to go into it much, but the annex only to show more of the data obtained, and we can see that the hair and blood samples showed in highest values of the 202 isotopes of mercury. To conclude with the part of the results, with the results obtained, the formula presented below could be made, which serves to show the top values of 202 and 199 isotopes. The variables shown in the formulas represented the following isotopes: 202 mercury rise model and 199 mercury rise model. Refer to the isotopes 202 mercury isotopes model and 199 mercury isotopes value in rise. Phi is the fraction of mercury in rat tissues and feces and total body load. Isotopes 202 mercury I and 199 mercury I are the 202 mercury and the isotopes 199 values in the rat tissues and faces. Conclusion. To conclude, I would just like to read the conclusion diplomat by the research which is following in this study. We deployed a model of mercury consumption in rats to evaluate the toxicokinetics of mercury using the theory of mass balance, and CAP approach. The highest accumulation of mercury, T mercury, was observed in the kidney. Approximately 18 of the ingested mercury was recovered in the rat's body and excretion. Excretion represented 55 of the total recovered mercury, and feces were the main route of elimination. However, only 32 of the feeding methylmercury was recovered, indicating a significant decrease in methylmercury methylation in the rat body. We confirmed fraction of 202 mercury in hair and blood samples and net negative fraction in feces at the deviation of 2 percentage has been obtained in the values of 202 mercury served on the care of humans who consumed mercury-contaminated fish, but the missing negative signal has yet to be explained. We found a negative net fraction of isotopes of mercury 202 in feces, which confirms that it is the main route of elimination of mercury. Our findings indicate that the mass balance method and mercury isotopes are useful tools understanding mercury metabolic process upfront. The demethylation of methyl mercury in the intestine was the important detoxification process in the rat's body, and in general I found the whole process carried out interesting, and I still find the fascinating how all these processes are carried out. I hope one day in my life to be able to something like this. And this, I conclude the presentation with with the next. My name is Christian Josue Muñoz Ramos, and this was a presentation for the Master of Balance and Energy for the 4 units. Thanks for watching.